Here is the second optimization problem from the work on differentiation. So if you could go to this booklet, and again it's I think the last example in the booklet, you'll find this example here, which is a little bit more complicated than the previous one. We've got a square based glass display case. Tells us the volume is 500 cubed centimetres. We're told the length of the base is x, and we're also told that the base is not made of glass. And we have to show that the area is given by this formula here, x squared plus 2000 over x. A really common mistake people make when they're trying to tackle this is they often start with this formula and try and do something with it, but this is the end point of this question. We've got to try and reach this point. And as in the previous example, some important things you should do. Begin by drawing a diagram. So we've got a diagram here, simple diagram. We know it's a cuboid rather. We know the volume, etc. We're going to need some basic maths, and well, we'll explain the rest as we go. So the first thing, just to make the diagram a little bit more useful, is to put on some information to it. So it tells us that it's a square base and the length of the base is x. So that means we've got an x here and an x here. And the thing we don't know, of course, is the height, so we'll just put in letter h for that. It says use basic maths to find an initial expression for the area. So we're trying to find out about the area of glass needed. So we're going to have the area of the top plus the area of the sides. So the area of the top is really straightforward. It's just x times x squared. And each side is just x by h, and there's 4 of them. So it's 4 times xh. And that's an expression for the area. Isn't quite what we want to do, because we want the expression in terms of x, and what we've got has an h in it. So we need to use the other piece of information, the fact that we know the volume is 500. We need to try and use that piece of information to get h in terms of x, so we can then go on to replace it. So we should probably start off, of course, with recognising that the basic formula for the volume of a cuboid is length times breadth times height. So in the case of the cuboid we've got here, it's x times x, that's x squared, times the height. Since we know the volume is 500, that becomes 500 equals x squared h, and it's just a case of rearranging that to get it on its own, to get h on its own. So we get h equals 500 over x squared. We then go back to the expression we had for the area. And we replace the letter h with 500 over x squared. So now we can cancel out this x with the x squared, which gives us an expression for the area in terms of x now, which is x squared plus 4 times 500 is 2000, and we've got an x on the bottom. So that's what we were asked to do for the first part. We've shown that the area is x squared plus 2000 over x. So that's the first part of the question done. People quite often find this first part the most difficult. What's worth remembering is you can always go on to the second part of the question. Even if you can't manage the first part, you can use the answer that's been given in the first part to continue with the question. Let's do that now. So for the second part, it said find the dimensions that use the minimum amount of glass that still gives us a volume of 500 cube centimetres. So we've got our expression for the area is x squared plus 2000 over x. In order to find a minimum area, we need to differentiate. So before we can differentiate this, we need to change it into a form that we can differentiate from. So we need to take the x to the top to make it x to the power of minus 1. And now we can find the derivative of that. We get 2x minus 2000 x to minus 2. And because we want to work with this, it's a bit awkward to work with negative powers, so we're just going to rearrange that to make it that. So we get the derivative is 2x minus 2000 over x squared. We know that stationary points occur when the derivative is equal to 0, so we essentially need to solve this equation. And that's a little bit more difficult than we've done previously. We'll try to solve this equation here. The thing that makes it look awkward, of course, is the x squared on the bottom, so we can deal with that by getting rid of it by multiplying everything through by x squared. So we end up with 2x cubed minus 2000 equals 0. And we're essentially now just solving this to find out what x is equal to. So if x cubed is equal to 1000, then x must be equal to 10. We then need to make sure that that value x equals 10 gives us a minimum value. So we know when we need a nature table. So when we put 10 into it, we know that the derivative comes to 0, but we need to consider what happens with something slightly smaller than 10, so maybe 9 for example. So we're going to evaluate what that comes to. So the derivative, when you substitute 9 into it, gives us 2 times x, so in this case it's 2 times 9. Take away 2000 over x squared, which is 9 squared 81. That gives us 18 minus something round about 25. So that gives us a negative answer. Then we need to consider something slightly bigger than 10, like 11. So when we put that into it, we get 2 times 11 is 22. Take away 2000 over 11 squared, which is 121, which gives us 22. Take away something round about 16, which gives us a positive answer. It is important that you show the working, this working here, showing that you've actually worked out what this is and worked out what this comes to, rather than just substituting these numbers in here. Okay, the markers will be looking for evidence that you've actually done that. Which gives us a slope, a negative slope, horizontal, and a positive slope, which tells us that when the area shows that the area is a minimum when x is equal to 10. So we know from previously that when x equals 10, the height is given by 500 over x squared, which is 500 over 10 squared, which gives us 5. So the dimensions are the length is 10 centimetres, the breadth is 10 centimetres, and the height is 5 centimetres. And the minimum area is 10 squared plus 2000 over 10, which gives us 100 plus 200, which is 300 squared centimetres. Now if you continue with the examples you're directed to.